As kind of an intellectual exercise, I sometimes like to ask myself, what is gravity? And the answer has been pretty similar lately. It's basically, I'm describing it as the curvature of the space time field via the presence of matter and energy. So the space time field is really just kind of like a 3D grid that has every possible XYZ coordinate embedded at every point. But at every point, there's also a temporal coordinate. So it's technically a 4D grid. And this grid can curve and warp depending on how much stuff is inside of it. The more matter and energy there is, the more it's going to curve and warp. As you stick stuff into this grid, space will start to crunch and kind of compress and get smaller, but time will start to expand, and it will take longer for events to unfold because the fundamental kind of time-keeping device that seems to govern reality will, it will be in flux. It will change depending on which part of space you're in. So you start you start putting matter and energy into any given space-time field, and the grid will just start to change. And we're plastered here on Earth because Earth is pretty massive, so the curvature that it creates in both space and time, there isn't going to be a whole lot of difference between the time here and the way time operates like in a vacuum. It's going to be pretty close. But space definitely gets crunched enough that you just get slammed into the Earth if you stop resisting and just kind of allow yourself to fall over. And objects that get close enough to the Earth are obviously going to either spin around it, or if they get even closer, they'll crash into it. So the curvature of space around here certainly is enough to, pull us toward the Earth, and we kind of stop at the ground level. But, if you're floating out in space and there's nothing gravitationally attracting you, well, then you're just going to kind of move in a straight line. And once you get close to a gravity field, like the ones generated by our planet or the moon or the sun or whatever, you'll keep going in a straight line, but that line will get curved. It's kind of a non-Euclidean thing. In Euclidean space, everything is kind of thought of in terms of straight lines. And in non-Euclidean space, a straight line can curve. Like if you try to draw a straight line on a globe, it will start to curve pretty quickly. So that's kind of what's going on with objects that move through space. They are technically moving in a straight line, but there's a kind of four-dimensional curvature happening that changes the way that it moves. So, the moon can spin around the Earth, or can orbit around the Earth, or Earth orbits around the sun. The sun is kind of moving along with the rest of the stars in the galaxy, and there's always some kind of motion attached to everything, because everything that is matter and energy is kind of changing the curvature of everything, and thus changing these straight line pathways into more or less curved pathways. So that's about it. I think that's an okay definition. I'm by no means an expert. I'm not a physicist or anything, but I kind of like where I'm going with this definition, because I think it feels like it makes more sense to me than it used to. I think as I learn more and kind of go over this mental exercise more, I start to understand it better. But I could be really off with this. If I'm really not being accurate here, I'd love to have someone come in and correct me and say, like, this is not, maybe this part was right, but a lot of this was wrong, whatever. In either case, I'd like to think that I'm getting better at understanding this sort of thing, and hopefully this particular definition makes sense to you, and kind of makes sense to me. But anyway, we'll do this again sometime, so bye-bye.